Okay, girls. Yeah, read out. Everything is fine. Diagrams are okay. No problem. The diagrams should be indicated. At C, did we do? At C, we did, but we got the same size. Yeah, fine. Okay, now let's begin with our class. We have completed 4 or 5? 4. Four positions we have completed. Isn't it? Now we are going to do address. We are going to continue with array diagrams. Okay, now that we have started, I don't want any discussion. Okay, unless you have some question to ask, you will please ask me. Right? We are going to continue with array diagrams. One position number 4 we have already completed. Today we will do position number 5. Okay, so your object here is at F. What is F? Focus. Focus. Okay, so we draw as usual our principal axis. Start. We are going to draw the concave mirror. Show the position of the pole, focus, and the center of curvature. Okay. I'm drawing an object, and this object is going to be indicated by AB. Okay, so this is your position number 5. So, a ray which is parallel to the principal axis, after reflection passes through where? Passes through the mirror. Yeah, look at the, everyone look at the diagram here. The incident ray parallel to the principal axis. After reflection passes through the focus. Okay, so it passes through the focus here. So I've already given you what are the different rays that we can take. The very first ray is passing through the focus. Here, this is the position that I'm talking about, position number 5. Now, have you started drawing? Completed this one? Okay. Which is the second ray that we can take? We can take a ray which is passing through C. Right? So we have a ray which is going to strike the mirror and which is passing through C. You will notice that this ray is nothing but the radius. Correct? Okay. So when this happens to be the incident ray, the reflected ray is also along the same path. So these are the two reflected rays. Right? And you find that these two rays keep on moving. I mean, if I draw correctly with the scale and all, you'll find that these are almost parallel to each other. So the dotted line shows that the image is formed somewhere at infinity. Okay. So this is at infinity. So object is at F, we already have written. Now let us write what are the characteristic features of the image. Position, size, and the nature. Position we already have seen that the image is contact infinity. So this is at infinity. Size is obviously going to be extremely enlarged, highly enlarged. It's going to be very huge. Okay. What do you think is the nature? Anything that is formed on this side, you notice all the images that we have done so far are formed, okay, on the left hand side along with the object. So it's obviously going to be real and inverted. AB is our object. Good evening. Good. Anush, you want to sit there? You want to sit there? You missed my first class, right? It was a double period. AB is the object. We are talking about the incident ray parallel to the principal axis. After reflection passes through F. Okay. The other ray that we can take, there are three rays I gave you. You can take any of those rays. The second ray is saying passing through C. So from here, passing through C, this is the ray which strikes it, comes back on the same path. Did you notice that C to this part of it is nothing but the radius? Okay. So that's the radius. That means at this position it's a normal. This is normal. So any ray which is striking at the normal will come back on the same path. So obviously it is going to form again. Now we talk about the last image. This is your image number 6, or position number 6. Yeah, okay. Okay. Shall we start with 6? Right. For 6, now we are talking, look at the board now. And did you notice what is happening on the 6 diagrams? Look at the board, everyone. Object was very far. Okay, it was at infinity. It's coming closer and closer. It is beyond C. Second position. Third position at C. Fourth position is between C and F. Fifth one was at F. This is what at F. Now if it is coming closer, what will be the position? Between F and O. That is what we are going to do. So this one, I'm still going to draw the concave, the P, F, and let us say this is C, and your object is between F and B, and I'm writing it as AB. Okay, so your object is okay. Let's see what is going to happen. One ray parallel to the principal axis. What will happen to this ray? Passes through F. So it is passing through F. What is the other ray that we shall take? Something like this. Passing through C. Okay. So we will take this ray passing through C Did you see that? Yes. What's happening? It's obviously moving on a far away, no? See? Like that. So obviously it is not going to meet anywhere, right? So what we are going to do is extend this line behind the mirror and see where it is intersecting. So you can extend your principal axis. Somewhere behind you will get an image. Why did I draw in dotted line? Because it is a virtual image. And a virtual image is never inverted, it's going to be erect. So that's why I'm going to draw like this. So how do you draw your virtual image? Dotted line, and it is going to be erect. Write it as A dash B dash. Do you understand? Please. Any ray that we draw behind the mirror is going to be shown in dotted because there's no ray. The ray cannot pass through the mirror. So it's a virtual ray. There's another additional line that they have drawn there. Don't draw that. This is enough, more than enough. Okay? One ray, this is one ray passing through F, the other ray passing through C, and you extend it behind. Use your scale and you get an erect image. Extend the principal axis. Principal axis is after all an imaginary line, so it can be extended. Without bending. The line doesn't bend. This line does not bend. It is keep your scale and draw a straight line ahead. There's one more, and there's only that is they're just showing you that it is, that C, the line which is passing through C is actually nothing but the radius. That is what.
And there's something like angle of it.
That's what I'm saying. That C part of it, this line which is passing through C is nothing but your radius. No? That part of it, there is. You say? VSH. It doesn't stop here. Manish, did you show? Did you draw? Did you get it? Did you get it? Oh, that's correct. Yeah, that's correct. The only thing is here also you are bending it. See, there's no bending at all. You should not bend. You should just continue along the line. Is that okay? So you can just take a very small object, just about one line in your notebook, so that you get a very comfortable virtual image. Now let's see what is the image. What is the position? Okay, what is the size? And of course, what is the nature? Put a star for the nature because this is the only image that is virtual and erect. Position, what will you write? Where is it formed?
Between F and B.
Behind. Behind the mirror. Okay, so you write this as behind the mirror.
Image also behind image.
Image only I'm writing. I'm writing about the image only.
Size.
Size, what do you think as when compared to the object?
Large.
Enlarged. It is big. Enlarged. One ray passing through and the other ray passing through C. Only thing is draw this as a dotted line. Yes. Yes. Is that okay, children? Okay. Remember to draw these arrowheads. This arrowhead. Incident ray striking the mirror. Okay, reflected ray coming back on the mirror. Okay, now let's see where we are going to. Why should we use a mirror like this and concave mirrors? Okay, so we have seen that depending upon the position of the object, we get different images of the. Okay, we get different sizes of the various images. Now, when do you think this will be useful? When we want an image which is going to be erect, not inverted. Did you understand? Now, most of you do know that in the entertainment industry, we have got actors, models, okay, who need to do a lot of makeup. Okay, so that's when they use such type of mirrors. A concave mirror with a very large focal length. So if you keep the mirror closer to the face, you get an erect, okay, image, so that they are able to complete the makeup. Similarly, it is also found in the shaving mirrors. Okay, so for persons, if you go to the barber shop, you will be able to find such type of mirrors where this is your face. And where should the face be kept? It should be kept very close to the mirror, okay, such that it is in between F and B. So what type of an image will you get? You should get an erect image. There's no point if you find yourself ulta, no? Right? So that is when we are going to be using it. Did you write? Write there for you to remember. Use in shaving mirrors. Okay. So now if you are talking, has everyone finished? Finished? Okay. Now we have finished all the 6. So all these 6 diagrams are over. Manush, you were not there. These 6 diagrams we have already completed. And the characteristics of all these things is given in the page before. Did you notice that? In the table here. These are the characteristics we have already written. Are we okay? Now we come to the table, a small paragraph which talks about the uses of a concave mirror. Concave mirrors are commonly used in torch. Think about it. Searchlight and vehicles in the headlights, okay, headlights of the vehicle. So when the car is going or when the vehicle is going, what type of a beam do you require? You require a very strong parallel beam so that you can see obviously which is in front of you. Similarly, in a torch that you hold, you should have a beam which is very, okay, very parallel to each other so that you are able to search. So where do you think of the 6 diagrams? Where do you think I put which diagram will be useful for us? Which one? Sixth one, no, this is an image. No, you're getting a virtual and an erect image. No, we are talking about a parallel beam. Just look at the diagrams and see where you're getting it. See the first diagram there, first one. Okay. Did you see the first one? What is happening? Right? The object is here. Okay, the object is somewhere here. You are finding that the ray is parallel and cuts through the focus. What if the bulb is kept here? Suppose you are having a concave mirror and you are having the bulb which is kept at the focus. What is going to happen? Ray, this is an incident ray, this is an incident ray, striking the surface of the mirror. After reflection, what will happen? It will become parallel. After reflection, it will become parallel. Did you see? Where are we getting a parallel beam? Okay, when in the first diagram, correct? Where the bulb is kept at the focus, so that you're getting a parallel beam. So the next time you use a torch, notice how the surface is. Have you seen the torch? It's a nice concave surface there, and there's a bulb which is kept here. Okay, so where is the bulb kept? It is kept at the focus. Mark it in your textbook. For torch, the bulb is kept at the focus, or even for the headlight, the bulb is kept at the focus. Okay. Searchlight vehicles so as to get a powerful parallel beams of light. They're often used as shaving mirror. Which diagram for shaving mirror? Just now I told you the last one. Okay, the diagram number 6 for the shaving mirror in order to see the large image of the face. What about the dentist? The dentist is using a concave mirror to see large images of the teeth of the patient. Okay, so that's once again here only. So whereas the tooth is going to be kept very close, so that the doctor is able to see the damaged tooth and therefore he can give the right prescription. And look at the last line. Large concave mirrors are used to concentrate sunlight to produce heat in the solar furnaces. Solar furnace, what is the meaning of the word furnace? Heat for cooking purposes. Especially if you go to these huge religious temples and all that, no? Where they do that annadana. Okay, that is where they are using solar reflectors. Not reflectors, it's basically nothing but heating. So what we do in the first diagram, look at the very first diagram, you are catching the sun rays and you have got huge concave solar mirrors such that the rays are falling on it. Once again, it is getting focused. So at this focus, you are keeping your vessels on full for cooking purposes so that it generates right amount of heat. Is that okay? So such type of questions can be asked in your application type of questions. So not only have we learned the ray diagrams, but we also need to know how to interpret where it can actually be used for day-to-day activities. Right? Could I take one then? Right? Any of these diagrams where what is used, why it is used, not just where it is used. You have to interpret. Maybe they'll ask you with respect to this draw a diagram. So you must select the correct diagram and also draw it. Did you understand? Suppose they say solar furnace. Draw a ray diagram for that. Or somebody wants to burn a piece of paper. Which diagram will you use? First diagram. You remember first diagram? You're keeping a piece of paper where this is the mirror. You're keeping it at the focus. Why at the focus? So that the sunlight will be focused at that particular point. So obviously the paper needs to burn. Okay, fine. Image formed by a convex mirror. Come back now. So today we have completed all the 6 diagrams of the concave mirror. We've already spoken about the spherical mirrors and now we will talk about the convex mirror. You remember this convex mirror? Where is the silvered surface? It is on the inside. Okay, suppose you complete this here. Where will C be? What is C? Center of curvature. So where will it be? It will be inside the face. Okay, so it is going to be somewhere here. So this is going to be C. This is going to be and half of this would be dead. So the first change that you find, what is the difference? Where is the focus for a convex mirror? It is behind the mirror. Whereas for a concave, it was in front of the mirror. Okay. Now if you notice in this diagram, come to page number 141. How many diagrams we have? Only two. Only two. Okay. First, let's try to understand. Have you ever seen a convex mirror? Everybody would have seen it. Where?
You go into malls, there are
Very good. Car parking area of the mall, you have got huge convex mirrors, isn't it? Also, spoon, of course, if you turn it around, obviously. All of you have a vehicle, I'm sure about it, two-wheeler. Yes, you always have a small mirror there, isn't it? Suppose you're driving a car or whatever it is, there's a small mirror to the side. What is that called? Rear view mirror. Rear. So I can see the vehicle which is coming behind me. What is the size of that image? Will it be big or small?
Small.
It will be small. And also something will be written. No? The images, it appears to be, yes. So, whenever we talk about a convex mirror, the image form will be much smaller than the actual object. Suppose there's an ambulance coming behind me and I have to give way. So I look into the rear view mirror. I know that there's a vehicle coming and I have to turn. Okay, so let's see. There are only two positions. Look at the first position. Draw the diagram. How will we draw? The same thing like this. There's no need for you to draw the dotted line. I've just shown you that it is a part of a spherical mirror. So we have got P and we have got an F and a C. Let's say the object is quite far off. So I'll say this is an object which is identical. Obviously, you are having rays of light coming and striking parallel to the principal axis. Why do you think there are dotted lines there? Why do you think we have started with a dotted line? It's very far off, so we can't draw all of them. Okay, so we just draw dotted lines, parallel lines. What are these rays? Incident rays. Okay, so it's fine. Will it be a convergent mirror or is it a divergent mirror? It is going to diverge it, okay, because it's moving away. Okay. So now after striking, you will find that it is moving away. Now this ray will also move away. But look at the board. One minute, please listen. Okay, so obviously you know that it's never going to meet. So what do? We extend this ray behind by using a dotted line. We extend this line by using a dotted line and we find that it is going to meet at L. So how are we actually going to draw the diagram? Everyone has a scale. This is what we are saying. Right. So how are we going to do? From P, listen very carefully. From P, you are going to take 2 and 2, 2 and 4 or whatever it is. Or you can also take 3 and 6. From F, okay, make sure that it is a straight line. Okay, there should be no bending. From F, draw a straight line such that there is no bending. So wherever it strikes here, from there is going to be a ray. Come to ray. Now in the textbook they have given you the principal axis also as one of the incident rays. Obviously the reflective ray will come back in the same direction. Finished? What do you think will be the size of the image? Will it be large? Will it be small? Extremely small, no? Because it's formed only here. Correct? It's going to be extremely small. Highly diminished. Correct? So size will be highly position. Where do you think it has formed? It has formed behind the middle. And nature, of course, will be what will it be when it is virtual anyway? Anybody into sports? Basketball? Obviously, we know that any field has to be lit up. For example, even a street light for that purpose. Okay? So this is what we are using. You find that the surface is convex. You're having a bulb or something of that sort here. When the bulb forms on the convex surface, it is spreading out. So that entire basketball court is actually lit up. Or maybe the street is also lit up. Okay, for such purposes we are using. That's where we are using a convex surface. Yes? Mention it, make a note of it. To light up a street lamp, okay, or any portion or any place where you need to have a wide amount of light coming in. Spread out. So this is your position number 1. And now we are going to talk about the other position. Once again here, draw the principal axis, show the convex mirror. This is the pole F and C. Now in the first position, the object was very, very far away. But in the second position, I brought it slightly closer. So it is somewhere in front here. Let's say it is AB. Okay? So as usual, we have one ray parallel to the principal axis. Will it pass through the mirror? No, it will not pass through the mirror, right? It's moving away from the mirror. It is a diverging ray. So when it's moving away, I use this. This is how it you are going to draw. Reflected ray. But when you extend this reflected ray, it appears as if it is coming from focus. Done? What about the second ray? We'll take a second ray passing through C. Okay, this is your C. Look at the board. This is your C and another ray passing through C. So it appears as if it is coming from C. And just draw your dotted line. As if it's coming from C. But this is where we are going to be talking about the ray. So this is nothing but your radius, which is your normal. So incident ray and the reflected ray is in the same direction. Appearance. I've drawn it in black here so that you understand. This is the second ray that we have taken. Okay. This ray appears as if it's coming from C. So how will you draw? Keep the scale from C right up to the tip of A. Here you will draw the dotted line, from here you will draw a straight line. Because this is nothing but your radius. Okay. So the ray which is coming from the radius is nothing but the normal, so it will go along the same direction. Children, did you notice that it is intersecting somewhere here? Those two rays are intersecting there. So that is where you are going to get a small virtual image. How did I draw the virtual image? Small dotted line like that. Okay, so you will write it as A dash B dash. That's our A dash B dash. Okay, so now we can write down position, the size, and the nature. Now this is nothing but your rear view mirror. Did you see that? What do you think is the size of the image? Is it big or small? It's small. It's obviously going to be diminished. So the size will be diminished. Let me do the otherwise because of this. Okay. That approximately that sense. Manish, what did you draw? Okay. So what do you think is the nature? Where has the image formed? It is formed behind the mirror. So obviously it is going to be virtual and what? Erect or erect? It has to be erect. Okay. Okay. What do they? Okay, children, what about the position? Where do you think it is formed? Between? Always. Okay, always the image is formed between P and F. Okay, and this is, what is the use here? It is used in your rear view vehicles. Okay, the mirror which is used for rear view.
Ma'am, here the position of the object is written as between infinity and the P, and the position of the image is written as the P, between P and F.
Between infinity and
But you have written position of the object
for the second one you are saying. Between infinity and the pole of the mirror. This is the pole. One minute. This is the pole and this is the infinity. So your object is in between the pole and infinity. Okay. Position. Sorry. This is position of the image. What I have written is correct. This is the image.
position of
Image is correct. No, this is between P and F only. This is correct. Image. There are two columns in your textbook. One is an object. Object is here. And what I have written is for an image. That is correct. Okay. So one of the most popular questions which is going to be asked is, turn the page. Can you see use of a convex mirror? Can you see that? Okay. Convex mirrors are commonly used as rear view or wing mirrors. These mirrors are fitted at the side of the vehicle, enabling the driver to see a traffic behind. Therefore, you can have safe driving. Children, can you look at your textbook? Look at your textbook. Turn the page and come to the paragraph. Yeah. Convex mirrors are preferred because they always give an erect and diminished image. Will it be advantage if it gives the same size? Can we use a plain mirror to the side? It will give the same size as the object, but then it will not give us any advantage because we want to see all other vehicles coming behind. So it has to be erect, it has to be diminished, okay, so that all the other vehicles can also be seen. Underline that very carefully. This is one of the questions which is repeated in many of the tests, examinations, board examinations, everything. Also, they have a wider field of view. Wider field of view. That means we can see many more things around us. Okay, as they are curved outwards. Therefore, it enables the driver to view much larger area than it will be possible with a plain mirror. Do you understand? Why don't we use a plain mirror? Why should we use a convex mirror? Obviously, because the image is diminished, it is erect, okay, so that we can get a wide view. Is that okay? Right. Then come back to the previous page. Only two positions for the convex, right? And we have already completed this table also. Whatever is given in the table, I have written it down like this. So for each diagram, you know which is it. Now did you understand, children, this part? Go back to this page. There's a convex and a concave, I have always told you, right? Now I want you to look at the convex part of it. The first diagram for convex. This one. Okay. What's happening? Incident ray parallel to the principal axis. After reflection, appears to come from where? Appears to come from air. Okay, that was one. And look at ray number 3. Point number 3. Look at ray number 3. See the convex one. Did you see? That is the same thing that we have used here. A ray which is passing either through, appears as if it is coming through C. That was the line. This is the line that we have used. This is the line that we have used for the diagram. Is that okay? Only two diagrams, so that is it. Are we comfortable with the ray diagrams? Now, what type of questions can be asked? One is they may give you only a part of the diagram and they may ask you to, sort of complete it. Or they may give you a ray diagram and they may ask you to solve problems based on that. So we have to be thorough with. And of course, give statements and duties and application type of questions, etc., etc. Okay. Next. Let's see here. Questions. They are in-text questions. Define principal focus of the concave mirror. You've been able to write. I've given you for homework. Okay. Put a tick mark. First one is over. Radius of curvature is 20 centimeter. What is the focal length? Here, in text. Obviously. R is equal to 2F, therefore F is equal to R. But you have to write the formula. Okay, for question number 2, we know the answer, but in the examinations, the teachers will expect you to write down where R is equal to 20 centimeter, R is equal to 2F. Therefore, your F is equal to R divided by 2, which is equal to 10 centimeter. Okay, so the formula needs to be shown. Correct? If you just write the answer, no credit. Okay. Third one. Name a mirror that can give an erect and an enlarged image of the object.
Concave.
Now we have 6 diagrams of the concave mirror. Yes. And we have got 2 diagrams of the convex. So look at the 6 diagrams of the concave. Are we getting an erect and an enlarged image? Where are we getting it?
6.
Yes, position number 6. That means if the object is kept within the focal length, that is when you're going to get an enlarged image. Okay. My other question, which has also been asked. There's a virtual image. Pay attention. Now I'm asking you something. We have done concave, we have done convex. दोनों में आगे हमारा virtual image. What is the difference between virtual image formed in a convex lens, mirror, and in a concave mirror? Look at the diagrams again. In a concave mirror, as when compared to a convex mirror. In both of them, I am talking about a virtual image.
Both of them are formed behind them. What is the difference in concave?
Difference.
In concave,
In-
it's formed behind.
Convex, it is formed behind.
In concave one.
Sixth one. It is in
The
concave
image
front.
formed is the enlarged and the image formed in the
Is
convex
small,
is
yes.
diminished.
Yes, that is one difference that you should remember. In a convex mirror, the virtual image is always diminished. Make a note of it quickly. Okay, here it is diminished. Whereas in a concave mirror, are we good? Sometimes such trick type of words are used in the questions. So you will have to understand how to answer it. Okay, now I'm asking you another question. Are you listening?
Yes.
I'm giving you 3 pieces of mirrors. It's a broken piece, huh? But you're not supposed to be touching it. You understand what I'm saying? Pay attention. Huh? It's a very nice question. Suppose I'm having 3 pieces. One piece kept here, one here, one here. Imagine all the 3 of them are pieces of mirror. Without touching it, how can you make out which is what? What are the 3 types that we have learned? Plane, convex, concave. Okay.
By image.
By the image size.
Correct, Bolo. In a plane mirror, what will happen?
No,
Same.
So if you're standing in front of it, image will also be the same.
But
Chalo,
laterally inverted.
ठीक है, you can make out. You can move your hands, whatever it is, you can make out. So plane mirror, it is easy. You know what you have? Convex and concave. Bolo.
The image will be enlarged in concave and the image will be diminished in convex.
You're almost there. Add something to it.
You can say virtual image and we can.
Even if you go far away, what will happen? Suppose I'm standing in front of a convex mirror. If I'm coming in front or if I'm going behind, the image will always be smaller. It will be diminished. Did you understand? Got it? Now today when you go out, start looking at the rear view mirrors of all the vehicles. When you go to the mall, also see where the car parking is there. There's a huge one. Huge. So in a convex mirror, It is always going to be diminished. Whereas here, of course, it depends upon the position, how you change your, it can be inverted, right? Did you understand? Now we come to the next one, sign convention. Now these are rules that we need to take. I'm sure by now you have realized that there are certain things, that there are certain rules to be observed. When we talk about, pay attention, then we'll write down, okay? I want everybody to listen first and then we'll write. Right? Suppose this is the mirror that we have taken. What mirror is this? This is your concave. Right? We always are showing our object towards the left. Correct? So the distances are measured. This is our object. From the object to the pole. So your object distance is u. Okay? So what is u? U is from here to here. So this distance is u. Right? Image, obviously you have seen in your 5 diagrams, 5 plus 1. I'm always referring to as 5 plus 1. 5, maybe it is like this. What is this? This is your image. This is your image. Now, image distance is given by this alphabet V. Children, please again V, be careful. Sometimes your V is also like this, U is also like that. Please don't do that, okay? V should look like V, or you draw V like this. This is not accepted. U is going to be like this proper. Okay? So what is image distance? This is V. So we'll accept this V is also alright. That means from where to where? From your image to the pole. All distances are measured to the pole. So this is your V. Where is your focus? In a concave. Look at the diagrams. 6 diagrams. Look at it. Is it in front of the mirror or behind the mirror? In front only now. So if this is C, then F will be somewhere here. Okay. So the distance between F and P is going to be your focal length. So F is your focal length. Is that okay? So these 3 things I want you to remember. Now, another thing that you will notice is whenever we draw the object, whether it is for convex or for concave, it is always on the left hand side. You take down this and then I'll explain. Take down these things. Sign convention. Means these are some rules that we are going to be learning now. And these are rules that you will use to solve more problems. Right? Now let us see. This looks exactly like a graph sheet, right? The vertical line shows the x-axis, and this obviously shows the y-axis, x and the y-axis, okay? So all measurements are from the pole. Suppose I have kept a mirror, concave mirror. Where is the object? Object is always going to be on this side. This is my object. And this is your U. Correct? All measurements measured on the left hand side is going to be taken as negative. So if I say the object, which is your candle or whatever it is, suppose the object, which is a candle, is placed in front of a concave mirror. What are we referring to? Candle is your object. And it is placed at a distance of 20 centimeters. Let us say it is placed at 20 easy. Now you remember that it is on the left hand side. So क्या लोगे? Negative. So we have to write it as negative 20 centimeters. Okay, in the sum they will not give you as negative. They just tell you it is at a distance of, but when you take it down, that is when you have to take it down as negative 20. Okay. So we have a virtual. We have a real image. We continue. Take a break. We'll come back. All of you got this book? Yeah, this is what. You see that? What type of a mirror? Convex. Understand? Yes. This suppose. Everybody knows about this, right?
ये हमारे पास एक लाइट सोर्स है, ये है एक ग्रे मिरर और थोड़ा सा टैल्कम पाउडर। इसे जब हम फूकेंगे तब ये लाइट को स्कैटर करेगा और लाइट का बार हमें दिखेगा। अब लाइट
Basically, you are using what are the laws of reflection? You remember, right? Angle of incidence is equal to yeah. So just a demonstration to make it more reflective. That's it. You can also do if you are having a small pencil dial or whatever it is. And that of course is your law. And what is the third, the second law? The reflected ray, the incident ray and the normal diagonal. Sit about all these are for the later one. This we'll talk about it in the next chapter.
कर दी मैं बोला था ना